Smooth down, sound so down. Come on, pumped upness. Okay, so right now what we're going to do is learn about, what is that stuff called? Angles. So yesterday, guys, looking at y'all's grades, you improved them. Good job. Some people finished several assignments. Good job. Make sure grades, grades are due this week. I want to help you out, guys. Let me know. I did some parent phone calls yesterday. I did some, actually, student calls, too. They called and we needed help. Clarified it. Y'all need help? I'm here for you guys. Okay, so here we go. Start coming down 1 and 4. 1, 4, I'm sorry. Y'all see it? 1, 4. That's why when it comes to 1, 4, we're going to talk about angle measure. Just thinking about this, guys, I think we're going to test on Friday. First off, let me say good morning. Good morning, everybody. Morning. Morning, Keeper. Okay, we're missing a couple people. So right now, guys, let's copy down this. So I'm thinking test on Friday, guys. Everything we've learned so far, I need a test grade. We'll figure out. I think we'll have everything from 1, whatever we're at, all the way to 1, 4, 1, 1, all the way to 1, 4. Time is flying. If you think about it, 1/12 of the year is gone. What? Why 1/12? Well, because on Friday it's going to be 1/2 of the marking period, and there's 6 marking periods. So we have 1/2 of 1 gone, and we break all the rest up into halves. There's 12 in all, and we're done with 1. Wow. Time flies when you're having fun. Right, Neelis? You know it. Do it to it, brother. Okay, we're gonna get guys, be ready to type some answers and stuff into your chat. Okay. So we come out here, guys. We're talking about angle measure. When it comes to the angle measure, it's not. It's pretty easy. Okay, but just we need to know about some, like, again, this is chapter 1, so it's talking about I guess the tools of geometry, the how to talk about this stuff. So you need to know about how to talk about geometry figures, geometry words, geometry everything. That's basically what we're going to work on today. Continue to learn the vocabulary, still learn how to communicate in this class. Okay, so let's go back. Let's start the thing. So you want to classify, okay, you want to measure and classify angles. We won't so much measure. I'll show you how to measure. But when we go back to school, I have a whole bunch of protractors, a whole bunch of stuff that you can use to measure. And I want to see you doing it. Basically, I think there's a lot of issues in the very beginning. And I don't want to do that on this meets here. I don't want to confuse people or get people like frustrated. So we'll just wait till we go back to school. Okay, angle measure. We're going to measure and classify, and we'll identify and use congruent angles. So we're going to use congruent stuff, and we're going to talk about bisectors. Do y'all know what bisector meant? Anybody remember what a bisector was? No, bi, like a bicycle, 2. Okay, sector, just cuts it in 2. Cuts it in 2 nice equal halves. So let's jump into an angle, guys. Let's start talking about an angle. So I know when you did an Alex 1-1, it asked you about a ray. I don't know why it was there, but here is the definition of a ray. A ray is a part of a line. So if you think about it, the line goes on forever, right? A ray is going to be, it has one endpoint and extends indefinitely in one direction. So I'm going to say it's basically half of a line. So this is a picture of a ray. If you look at it right here, it goes from M forever off into the direction of O or P. See the arrow? So that's a ray right there. Rays are named by stating the endpoint first and then any other point on the ray. I like to say that's where it begins if you think about it. But this is the endpoint. You see that? Where it actually ends, and M goes off in the direction of O, or M goes off in the direction of P / those are your rays. The ray shown cannot be named OM. You can't start off with one of these and then go to M because that's not your starting point. Okay, none of these are your starting points. So there it goes. Let's go ahead and write this down. And write this down, please. The key stuff goes in your spiral. So write that down real quick. A ray is a part of a line. And then you're going to come out here and know how to label it, okay? So draw that, put those points on it, and you need to know that it goes ray and P. If you put this little line on top of it, okay? This way you would go M, P, and put a little ray, a little one on top. And there it goes. So write that down real quick. I'll give you a couple of seconds. I'm going to take attendance real fast. Let me see what you got. You know the code? Where's your Google Packet? Yeah, you should have it open. Where is that? Can you press that? Okay. Let's okay, we're back. Go to mom. Put that on happy. Tell me if this code. It's that code right there. You see that? E T I E 4 U F F F. Type that one out. Okay. Let me come back over here. Okay, guys, so let's come back over here. When it comes to this part right here, you want to come out here and talk about the rays in the right order. You have to start off with an endpoint and then go off in the other direction. Do you have any questions there? No? So I can move on? Let me know. Okay, regarding this part right here, you need to know this part. If you choose a point on a line, okay, so they're going to choose J, that point determines exactly two rays called opposite rays. So if you look at this one, guys, choose a point on a line. Remember, line is not a ray. It goes off in both directions. A line goes off in both directions. If you choose one here, like J, they chose J, you can choose any other one. You have where it says now they're two opposite rays. Since both rays share a common endpoint, opposite rays are collinear. There's some key words here you need to know. You should know them already. Ray, you know what that is. Now, opposite. This is opposite rays. It's just basically saying they go in the opposite direction, okay, from a common endpoint. If they do that, guess what they form here? They form this right here. They go off in directions that are direct opposites. They form collinear rays. What's collinear? Do you know what a collinear means? Anybody remember what collinear means? Good job. We're going to go with same line. So when they form opposite rays, guess what they make? A line. Pretty cool? They form a line. So if you hear out there, like this one saying here, ray JH, this way, and this JK, this way, are opposite rays, then we basically know that this here is a straight line. Make sense? Make sure you know that. So this means same line, right here, write this down here. Write that down, and they're going to put form a straight. Guys, I don't know how you spell straight. I think that's it. I always remember George Strait, so I always write like that. Form a straight line. So hopefully that makes sense. Hopefully you understand that. So you got to come out here and understand that two opposite rays form straight line. Okay, moving on. About 30 seconds. Okay, when it comes down to the straight lines, there's one other thing I'm going to add in there if you don't mind. If you hear that they form a straight line, I'm going to add this in here. This angle here, if you see that, is 180 degrees. Okay, so it's a 180-degree angle formed by two opposite rays. Make sure you know that too. I don't think it tells you in this book, but we need to start knowing that. Okay, it gets to it later, okay, but not right now. And it kind of assumes that you know that already. So an angle, right, an angle that we're going to talk about today is formed by two non-collinear rays. What does that mean, non-collinear? Thank you so much. So if they're not on the same line, so imagine if I had a line going straight here, that would be opposite rays. But you see this line goes like this, and now this other non-collinear line goes on a different line. So when two lines intersect, they intersect at a point. Okay, just saying that. So angles formed by two non-collinear rays that have a common endpoint. The rays are called sides of the angle, and the common endpoint is the vertex. So there it is. So I'm not going to tell you to write everything. I really don't want you to write everything. But you have to have this drawing. This one for sure. You know, this is side, right? XY. This is side XZ. The vertex is right there, X. You okay with that one? So if you draw the picture, it kind of gives you all this information. But if you want to go ahead and write all of this down, or you want to put it in your own words, I would. Remember, you do have the online book, so this is actually in your online book too, and you can even write on the bottom of your notes, page 36. But remember, this will be revisited all year long. We're talking about this as Chapter 1, and Chapter 1 is basically like, you know, the intro to geometry, the intro to how to communicate and talk about all the everything for the rest of the year. Okay, moving on. This blue part now. I'm looking at the blue part. I'm kind of boxing in. Now, when we talk about an angle, we don't just say whatever's there. We got to talk about it in a certain way. So when naming angles using three letters, doesn't mean you have to use three letters. When you're naming angles with three letters, see how there's several letters here? The vertex must be the second of the three letters. So this one would be angle YXZ or angle ZXY. Basically, the vertex tells you right now by looking at that, that's the common endpoint. And when you name it with three letters, that common endpoint is in the middle. Okay? You have two rays here. You look at this, you have angle XY, ray XY and ray XZ. So you would name the angle by basically saying that vertex is at the middle point. You can name an angle using a single letter. So looking at this whole thing right here, for this one figure, since there's no other drawings or other angles next to it, you can say that one is angle X easily. But if there's other angles there, you really shouldn't say it like that because, well, you can kind of throw people off. Which angle are they talking about? Ooh, so you don't want to do that. You basically want to come out here, if there's one angle, keep it simple. Angle X, angle 3, angle, real simple. Okay, you can name an angle using a single letter when there is exactly one angle located at this vertex. The angle here, this angle here, can be named as angle X, angle YXZ, and angle ZX, and angle ZXY. Or, since there's a number 3 there, on the inside you can say angle 3. Make sure you do know that you put angle in front of it. This little sign right here, you know, let me make that definite for sure. So if you see this little symbol here, that means angle. That is your, like, a shorthand for angle. So this means angle 3. This means angle X. This means angle YXZ. This means angle ZXY. Going once, going twice, not too bad. Okay, let's get ready, guys. Let's move it up. Move it on up. So make sure you know this goes with this information for that figure. Okay, ready? Moving it up now. When it comes to the angles, there's that red angle. Since the red angle, if you look at this, it's like on a flat surface. It's on a plane. When there's an angle, there's three distinct parts, okay? An angle is divided a plane into three distinct parts. So now there's three parts. What are they? The first part, looking at the points M, points Q, M, and M. You see Q, M, and M? You see that angle right there? So that angle there, if you look at that, that is your angle, and those points lie on your angle. All right, not too bad. Points S, R lie on the interior of the angle. So if you look at this part here, the smaller one, since an angle, if you look at this, could be really I guess this side, the angle, and this side. The smaller one would be the interior. The bigger one is the exterior. So copy that down, put the important information, and we're going to get ready for the next page. So next page is going to practice this whole page one, page how to talk about the angles. Okay, let's go to the next page. When it comes to the top part right here, this is the kind of, you will get this on your test. You will get some kind of situation like this. Now, if you look at this, look at those things, the streets as lines. Those are just points on the lines. The angles are here. Okay? So you really don't need to know about the faculty. You don't need to know about the auditorium or the library, the office. But look at the streets as lines. Look at the lines here and everything like that. So that's it. So coming down here, let's go to name all angles that have B as a vertex. Remember, B is the common point where the angles are formed by two rays extending off of that point. So let's look at that one real quick. Name all angles that have B as a vertex. So where's B? B is right there. Okay, so I'll show you this. I'll change it to red. Name all angles that have B as a vertex. So we're going to B, you can have this angle here. You can have this, I guess I'll change this one. You can have this angle here. Make sure, because B is my vertex right there. So we can name those different ways. Okay, so they're naming this angle here, angle 1. Check. I'll change it to red. They named this angle here by angle 1. Angle ABD. ABD. Okay, since they named it ABD, you could have it as angle DBA. What did I keep the same? The vertex. The vertex has to be in the middle. And I just switched out the other endpoints. And that's it. Not the other endpoints. The other, I guess, parts that form the ray. That's right. So far, that's that red angle. Let's look at this blue angle. Since this blue angle is here on this side, I can go ahead and say that one's what? Angle 2. Check. I can go ahead and name it as what? CBD. Oh, wait. It went DBC. We can switch that around. And do angle CBD. Cha-ching, bada bang. Going once, going twice. What do y'all think? Not too bad? Okay. You may get lost there. So yeah, guys, you gotta look at this real quick. When it comes to this part right here, you gotta look at that. They can name it how many different ways? 1, 2, 3, 4, 5, 6. 6 different ways. When you take the end of course exam, you will take it with paper. So your 6 ways, okay, of naming it, a correct way, could be mixed up with a bunch of other wrong ways of naming it up. So you gotta be ready that you know how to do it. When it comes to Alex, You can put any one of these names in here, and it'll count it right or wrong. That's why I like Alex a lot, because it's, you know, it has all those algorithms to determine if you're doing it right or wrong right away. Okay, letter B. Name the sides of angle 3. Angle 3, where in the world's angle 3? Okay, angle 3 is right here. So this is a side, and this is a side. Okay, so regarding that, let's come out here and look at the way the book named it. So look at this. When it puts these two together, that's talking about those two form the angle, okay? So CA, boom, that side, and CE. You go with CB and CE. Question on that one. Is there any other way we could name it? I don't think so, right? I think we did a good job here. Going once, going twice. You may not understand that one. Anybody need help? Your silence is telling me that you all are good. Madness. Okay, well, CK, well, regarding this angle right here, if you're looking at it as a straight angle, does that make sense? Then it would include 3 and 4. The angle 3 only includes these two sides. So you really can't use CKL there. You can't use that one at all. And actually, if you use CKL, you're saying that K is the vertex. And they want this part over here to be the vertex, which is the C. Monday. It is a ray. C to E. See it right here? Oh. Oh, you know why? Think about this. They didn't put an arrow here. Good catch. I hadn't seen that ever in all my years. Does that make sense or no? Okay, so by this picture, it says this street goes on forever in that direction. And this street goes on forever in that direction. This street does not go on forever. Make sense? It becomes just a what? Like a dead end going into the office. Just for that one example, makes sense to me. I didn't catch that, Jenna. Good catch, sister.
But it's not.
No, because a line would have the arrows like this. That's, yeah, the line segment there. Good catch. Yeah, it's saying that's a line segment. Sneaky, sneaky little question there. I had never seen that in all my years. Wow, pretty cool. Hopefully I answered your question. Just because I think that street ends there, that's why. I guess they really should have put an arrow, made it a ray. So how about that? In the real world, I guess that would be sensible, but you should have a ray here, especially since they just talked about rays. So that would go there, and then there would be an arrow there. Okay, good question, Jenna. Next one over here. What is another name for angle GHL? Where in the world is GHL? So GHL is down here on the bottom. GHL. Okay. So that angle there, okay, is the one that they're talking about. What's another name for it? Well, we can talk about that number in the corner, angle 7. Angle H, since there's no other angles here, you can kind of think about it. Angle H works. And they just switched up these letters. You see this? They did keep the vertex, the middle letter, and then they went out and switched out the G and the L, which makes sense. You can do that too. Going once, going twice. Is there any other way of naming that angle? I don't see it. Okay, last one. Name a point on the interior of DBK. Interior of DBK. So they're talking about D to B and then to K. They want one that's in the interior. What point would be on the interior? D, B to K. For the interior, we're going to go to the smaller side, okay? A point in here, point E, and point E. Good questions? I like them. What do y'all think? Anybody have any questions there? Okay, let's copy the, we're going to do these next ones together. I'll give you a couple of seconds. Let me copy these questions. Okay, copy that down real quick. Get that done. Okay, let's go. Ready? So what is the vertex of angle 5? Vertex of angle 5. Let's find angle 5. So angle 5 is right in here, right here. What is the vertex of angle 5? What do y'all think? 1A. We'll go with point C. Question on that one? Okay, let's go with 1B. Name the sides of angle 5. Name the sides of angle 5. Name the sides of angle 5. Angle 5 is here. ECG. ECG. Okay, so when it comes out here to naming the sides, it wants like this side and this side. Like one side and one side. So we need to come out here the sides, and what makes up the sides? Rays. All right. So let's go out here with C. Someone put CA, and CA would be this side, and CJ. Okay, so let's come out here and let's look at this one real quick. So I've answered wrong. I want to tell you this much. What's wrong with these two things? I need to put the, yes, I need to put the ray sign on top. Or I could put the word ray, right? So we need to put that there. Rays CA and CJ. So that's the sides of that angle. Is there another way of naming that one?
Yes.
Okay, line segment AC. Somebody put AC. Where's AC? So line segment AC would be saying going in this direction. Okay, Barbara, we have to use the C first. Jenna, you named 3 points, which kind of, I think you're trying to go into the angle like that. We want to name the sides. Okay, the sides of the rays. So let's come back over here. I'm going to switch it up. How about this? CA, somebody want CA? And I'm going to go with CB. Ray CB, and what other ray? CG. There it goes. So if you think about these two, I guess are the longer sides. These two would be the shorter sides. But then I could switch them up if you think about it. I can go the long side here and the short side here. I go with Ray CB and Ray CJ. Then I can go to, what's the other one here? Short side here, long side there. Ray CG and Ray CA. CG and CA. Okay, so those are two. Those are, I think probably all the combinations we can do. Any other ones? What do y'all think? Any other ones? Anybody? Cricket? Going once, going twice? I'm going to say, could you name them with the line segments? Yeah, why not? What do you mean, sir? Since those are the rays, couldn't I say line segment? Because they did that to us, or I'll go on the example. CB and line segment CG. Sneaky there. The book says a lot. So I think that's also a possibility. What I named there, you know what? I think they might be wrong if they do that. Because it's saying line segment. No, it's pretty cool because it does show that the lines, how do I say, both have an endpoint C. So I think that's also acceptable. Ready? Anybody have any questions over there? And I'll find myself on that one. Let's try 1C. Okay, let me erase all this madness. Why not, Jenna? Okay, so if you look at, Ava just put in the question right now, why not Jenna's answer? And if you get in the chat, Jenna, you're not in trouble. Thank you for participating. She put BCG. What is this saying here? I have no idea. Is it a line? Is it points? What is it? If you just name.
It's showing the whole picture of the this side.
Yeah.
It's showing the midpoint of the side.
Well, you need to come out here before. If you think about it before, when you put 3 letters, that was your plane. Remember that? But there are also capital letters. When you're talking about okay, yeah. If you name 3 things, I think you're trying here to go like this. Well, since we're talking about angles, yes. But mathematically or geometrically speaking, that's saying I have no idea what. That's saying 3 points. B, C, and G. Okay, cool. What about them? Well, the question was asking what are the sides. So it wants this side named, which would be BC, Ray BC, and this side here, CG. Oh, wait, not BC. CB and CG. And we have to put that. The question there is asking as far as what are the sides that make up this angle. It has to be in this form because if you look at the angle, it was made up of 2 non-collinear rays. This right here, without the word points, without the word ray, without the word plane, is just naming 3 points randomly there in space. Hopefully that makes your, hopefully that answers what you're trying to get there, you know. So Jenna's answer is wrong. I can kind of see where she's going with it. I won't lie to you, but it's not like a correct geometric answer. You actually want to put the words ray, or you actually want to put the words angle or the word plane in there. And I know it's kind of hard in the text thing to put it there. So like I love the way Ray, somebody put Ray, or look Barbara, she put line segment AC and Ray CJ. That's awesome. I know it's kind of hard. You don't have the symbols. I don't even know what these symbols are in the chat. But that's why that's wrong. It's just not saying anything. It's just saying point C or point B, C, and G. Let me go on. 1C. Okay, write another name for ECL. Oh, sorry. Write another name for angle ECL. Angle ECL. Okay, angle ECL. We're talking about this one here. Write another name for the angle. So we're looking for another angle name. How could I name this angle here? Well, first off, without even looking at this, what could I do with these things? Wait. Okay, again, Jenna, you put LCE. Okay, you need to say what? Put the word angle in the situation. Okay, so we're going to come out here without doing anything. I could switch this stuff around. Keep my vertex and put angle LCE. Make sense? Good job. I think somebody else put here, I think somebody said it. I wasn't looking at the chat, but you can put angle 4, right? You can put angle 4. So right here, Ava, I can't put the number 4. I need to put angle 4. I can't put LCE. I need to put angle LCE. Any other thing I could put? Ooh, regarding that one, look at that one. Angle C is also, well, in here. Angle C is also here. Angle C is also here. So which angle C are you talking about, my brother? So you can't put angle C by itself. What I could put by itself is angle 4. That one works. So another way of doing this one, we can do this one right here. ECK, angle ECK. Y'all see that? Any other one? What if I switch these around? Angle KCE. Any other one? What do y'all think? Wow, right? A lot? Craziness. Okay, I think that's pretty good. Guys, I'm not perfect here at all. I messed up a lot. You let me know. Somebody put ice baby earlier. I'm joking. I am. Because the L looks like an I. Bad joke. Bad joke. ECL. Isn't that the one that was given to us in the beginning? Burn, brother, burn. But yeah, that's why I was trying to look at that one. That's why I knew that one right away, because I was like, oh, that's the one they gave us. So yeah, I think that's all the combinations. Okay, let's go with 1D. With 1D, let's look at this. So name a point in the interior of angle CLH. C. Let me change color. C L H. I'm sorry, exterior. So if you look at this one, I'm going to go out here and draw the angle like this. So they want that angle here. They want the exterior. So we're going to see this one right here, if you don't mind, as the interior, the smaller part. So this side over here, on the outside over here, would be exterior. So exterior, yes, Barbara, thank you so much. Brandon, you put K. Where in the world is K? I think I covered it. They want it on the exterior. Thank you so much, Barbara. You do have to put, okay, on this one, you do have to put point, the word point, and then E works, or point E and what, D? Either one of those work. If you just put, I think somebody put in the chat, if you just put the letter K like this, you're talking about a plane, okay? Or you have to put plane or point, you have to kind of name what it is. I kind of lost in that area. Put, in this situation, point. So they're looking for a point. Going once, going twice, pretty easy. Not too bad, right? Again, it's just learning how to talk about this. We'll continue revisiting this and revisiting it and using it over and over and over. So we'll become professionals by the end of the, in no time. How about that? Okay, so real quick, this next part, we're going to kind of go through it / skip. The only reason, because they want you to physically measure. I would love for you to physically measure your, like this part, but we don't have, I got to see you. I want to make sure you're doing it right. I have a lot of protractors at school, so when we go back, we'll jump back to this. So angles are measured in the units called degrees. So if you look at all the degrees, how many is it? 360. The degree results from dividing the distance around a circle into 360 parts. Do not ask me why 360 parts. I've always wondered, never figured that out. So write that part. Angles are measured in units called degrees. Now, when it comes to this one, I'm going to break this up into 4 equal pieces. So there it is, 4 equal pieces. Each one of these is how many degrees? 90 degrees. So there it is, 90, 90, 90, 90. 2 of them together make 180. Does that make sense? So let me come on and move it on up. So basically write this, angles are measured in degrees. So when you come out here and actually measure and look at stuff like this, so if you look at the angle right there in the background, angle FED, the way you would measure this, guys, this is how you would measure it. Let me get a protractor and show you real quick. You'd actually get your protractor and the vertex down here. So when you have your own paper one, there is usually a little hole here, okay, or the one that you have as far as when you get a plastic one or whatever, they have a little hole here, and you get that corner and you line it up with a vertex, okay? Now, you see these, let me put it over here. These are your degrees on the outside. These are your degrees on the outside. You want this line on the bottom, or one of these rays, to be in line with the vertex right here, that was 0, that was a circle in the middle, and with one of these straight lines. The one of the straight lines that points to the zeros on the either end. So I'll put that here. Using this, look at the angle back there. Using this part here, I'm lining up this ray, and I look at the degrees to the other ray. I go physically up, looking up how many degrees from here to here. FYI, this is just me, you know, and you guys being smart. You know from here to here is 90 degrees, right? A right angle. From here to here, if I had this, this is 90 degrees. So when it comes to that being 90 degrees, I know that this angle here is less than 90 degrees. So when you extend it out here, this other ray, there's 2 numbers here. Okay, the outside one is giving you 1, and the other one's giving you the other one. Now, regarding this one, it's either 130 degrees or 50 degrees. But since you know this one's here less than 90 degrees, so it's going to be the one that's less than 90 degrees. That's one way of doing it. The other way is just look. From here, this would be the 0 going up, 10, 20, 30, 40. I've used or moved to 50 units. If you want to count from the outside, there's still an increment of 10, so you can go 10, 20, 30, 40, 50 degrees. So just FYI, I like to know before I look at anything, oh, the angle is less than 90 degrees. So when I come over here looking for the degrees, I'm looking for the one that's less than 90 degrees. In this situation, it'd be the inside stuff. Okay, moving on. Let me move on. Close this thing. We're going to skip the next example. But what I'll do is I'll show you how to do it real quick. Do me a favor, real quick. This is from elementary. Copy this down. Okay, so you have 3 types of angles. You're going to have a right angle, which is 90 degrees. You have an acute angle, which is less than 90 degrees. And then you have an obtuse angle, an angle bigger than 90 / smaller than 180. So copy those down real quick. Okay, let's do it to it. Move it on. So let me show you how to measure with a protractor. So there. So these are angles here. Now this whole thing is kind of 1 angle, 2 angles, 3 angles, 4 angles. You can look at the 5 angles, 6 angles. There's just a lot of different angles in there. So regarding this one, find the measure or find the angle MJK. Okay. Now we want to go to find the measure of that one. So I'm going to come out here and get, well, I'll get my protractor. Now look at the picture. Looking at the picture over here, okay? I'm going to find these endpoints, M, oh sorry, the vertex, and then go MJP, MJP. What do I notice right there in that corner? I notice that there's a right angle, so I'm going to say that one's 90 degrees. I'm going to prove it. I'm going to show you how to measure again. Get the thing, the protractor, line with the vertex, right there. Put one of the rays going to 0. You see there's my 0 there. It extends all the way up to 90 degrees, so yes, I was correct, 90 degrees. Let's try angle LJP. Okay, find LJP, L, J, and P. So if you notice, this one's bigger than 90 degrees. So I'm going to line it up again. I'm going to line up this ray with the 0 on the bottom. So I'll put that vertex right there on the bottom. Okay, line it up. And now this is pointing to 0. I'm going to go look for the L. L is over here. L is now between, you know, it's bigger than 90 degrees, so I'm going to ignore the 70 and 80. And it's now what? Between 110 and 100, so about 105. And there she is, about 105. Going once, going twice, not too bad. Okay, moving on. Let me go to the next section. No, let me close this. Yeah, we'll skip that. Okay, you do need to know this part up here. Congruent angles. Do y'all remember what congruent meant? What did congruent mean? Yes, ma'am, it did. Congruent meant the same, exactly the same, We'll go with equal. Okay, it meant that stuff. So let's go look at here. Congruent angles, just as segments that have the same measure are congruent segments. Angles that have the same measure are congruent angles. So once you hear congruent regarding the segments, or in this situation, angles or congruent figures, we'll get to figures later. Once you hear congruent, they're the same. In this figure, since the measurement of angle ABC, where's ABC? ABC is equal to the measure of angle FED. Since you see 65 here is here and 65 is here, then now we know that the angles ABC is congruent to angle FED. So because they gave me the numbers and they're showing me that the numbers are equal as far as degrees, then now I know the angles are equal. Matching numbers, okay, so matching number of arcs is also an indicator to let you know that the angles are congruent. So you see the 65 is right here and it has one arc. Just humor me, guys. Just say that you did not or don't see the 65 here. But you do see the one arc here and the one arc here. Well, what do you know about these two angles? Well, then now I know this one's 65. Make sense? Just FYI, I said I didn't know 65 here and I didn't know 65 here, but I saw the one angle. Well, eventually they give me this angle to be 65, then now I know this one's equal to 65. Pretty cool? Okay, now on the other side over here, we have two arcs. Well, this other arc is, well, I'm sorry, this other angle has two arcs, then now I know these two are equal. For this one figure, anything that has one arc are equal. For anything that has two arcs are equal. You understand that? Pretty cool? Not too bad? I'm going to add one more thing in here. Does anybody, or can anybody tell me how to figure out the angle, the measure of angle DEB? How would I find out the measure of angle DEB? Good job. I would actually get 180 minus that 65. I'm going to do the math real quick. Please help me and tell me if I did it wrong. I'm sorry if I got it wrong. But now I know when I get the 180 and minus 65, then we'll say degrees, which are we're talking about here. That means this one's 115 degrees slash that means this one's 115 degrees. Pretty cool. How do I know that? Because this is a straight line they're showing me kind of going off. Now when it comes to here and here, they have to add up to 180. So these two add up to 180. Okay, these two add up to 180 slash straight line. Perfect. Good job. So do me a favor, guys. Copy this for sure. and this part here. Okay, let's move on. Anybody need more time? Okay, do it to it. About 10 more seconds. Come on, Brandon. Quickness, brother, quickness. Okay, let's move on. So we're going to get this part right here. Angle bisector, guys. So a ray that divides an angle into two congruent angles is called an angle bisector. Okay, angle bisector. Let me think of the word angle. Okay, I know what an angle is. What does the word bisector mean? Good job. So if you have the word bisector, guys, that means to cut in half. So what do you think it's cutting in half? Well, if it's talking about angle bisector, well, then it cuts the angle in half. So regarding this, an array that divides an angle into two congruent angles is called an angle bisector. If ray YW, you see YW right here, is the angle bisector of angle XYZ, if that one bisects it, then the point W lies in the interior of the angle XYZ, so this has to be in the interior. And the angles that are, made from that cutting it in half, which are angle XYW and angle WYZ, that little line, that little thing right there, means that they're congruent. So FYI, if you know this one bisects the bigger angle, those two smaller angles are now congruent. So go ahead and write that out now. That's very important. We will visit and use this forever. So a ray that divides an angle into two congruent angles is an angle bisector. Draw this out real quick, all this good stuff, and make sure you know that angle bisector is this one right here. Okay, the angle bisector on that one is ray YW. That YW, guys, is the angle bisector resulting in two smaller angles that are congruent to each other. They have the same measure, same degrees, same number of arcs to show you. So I'm going to go and continue talking about this part right here. Since I know that these two are 180, both of them are 80, I'm sorry. What do we know about this big angle? Do we know anything about this big angle here? Do we know anything about this angle here? I'm sorry, the measure.
It's up to.
How do you? It's obtuse, and it's going to be 160. Well, what do you mean? Well, since I know the measure of these two smaller ones, it's like segment addition. If I have this angle here, and it goes 80 degrees up, and then I put another angle here that goes another 80 degrees, well, basically, I have an 80-degree angle plus another 80-degree angle, which gives me 160 degrees. So now I know the bigger angle is equal to 160 because it's the addition, or basically it's that one angle was cut in half. And if it was really cut in half, it had to have been 2 equal parts of 80, 80, making up the bigger 160. So just as with segments, when a line, segment, or ray divides an angle into smaller angles, the sum of the measures of the smaller angles, so the sum of the smaller angles, equals the measure of the largest angle. So in figure right here, this figure, the measurement of angle XYW, XYW, plus the measure of angle WYZ is equal to the measure of the angle XYZ, equals the big one. Now make sure you know that. It doesn't have to always be angle bisector. What do you mean? So I'm going to draw a cheapy right angle here, if you don't mind. If I cut it in like this, and I say this one's just humorous, just say I drew a 40-degree angle right here. What does this have to be over here? 50 degrees. Why? Because you see this right angle here? I'm not going to say it's cut in half, but it's cut into 2 pieces. And if I know this one's 40, this one has to be the other 50 to add up to the 90. Pretty cool? Not too bad? Copy that information down here. Well, you automatically know this part when they add up to equal the bigger one. So next page. Whoa, whoa, whoa. Some crazy stuff. Let's look at this one quick. In the figure line, ray KJ. Where's KJ? KJ. Okay, KJ. And KM are opposite rays. KM. Whoa, whoa, what does that mean? What's that telling me there? What is this telling me here? It tells me K. Yeah, this forms a line. FYI, that forms a straight line because it's saying opposite rays. Okay? So what I'm going to tell you that, now I know, because that's, well, really cool, right? They say opposite rays. Now I know this is 180 degrees, if that makes sense. Slash, what does that make this side over here? 180 degrees, because that's a straight line. Okay, moving on. And KN bisects, where's KN? KN bisects angle JKL. Where's JKL? JKL. So now I know this angle is equal to that angle. Those two are congruent. Good job. Guys, it's 10:30. See you tomorrow. Time flies when you're having fun. Jeez. Bye-bye, guys. We'll see y'all. Have a good day. Bye, guys. Good night. What? No. This guy. Bye. Bye-bye, guys. Be safe.